Hello and welcome to the second video about Infilink Modbus driver. In this video, we are going to get more information about following items. Driver tag data types and how the 16-bit register data is stored into them. Working with tag groups, CSV import and export of tags, advanced settings for channels and devices. So let's get started. Modbus driver tags with Boolean data type will be used to store data for coils and inputs, as they have only two states, on or off. You can also represent status of individual bits of registers with Boolean data type. Let us now look at remaining data types available with Modbus driver tags. Data types char and byte represent single byte. When reading 2-byte register data into single byte driver tag, only lower byte of register will be stored into tag. Data type byte is treated as unsigned. Data type char is treated as signed. While displaying data for char data type tag, driver will display equivalent ASCII character. Data types short and word represent 2 bytes or single word. As Modbus register is also one word data, it will get stored properly in tags with these data types. Data type short will be treated as signed and word will be treated as unsigned. Data types long and dword represent 4 bytes or 2 words. If any driver tag uses one of these two data types, driver will read data from two consecutive registers, combine that data as a 32-bit data, and store it into the tag. Data type long is treated as signed value and dword is treated as unsigned value. When the data is written into these tags, driver will split the data into two different words and store them into two associated registers. Tags with float data type use 4 bytes to store data. Driver combines data of two consecutive Modbus registers, does some math as per relevant IEEE standard, and stores that data as floating point data into the tag. When data is written to tag with float data type, driver will do reverse conversion and store that data into two consecutive registers. Now, let's understand how to use tag groups and import and export of CSV files. I am starting the driver, creating a new project. I am setting up my channel. I am setting up the device. Now we can create tags for this device. I am going to create one tag. And then just duplicate and make few more tags. For this device, I can have a tag group included in this device. For making a tag group, I go to tags and new tag group. So I can name the group as device 1 group 1. I can click on this group and go on creating the tags in this group. So let me do that. Click on create new tag and just duplicating, let me make few more tags. So we now see we have a channel. In the channel we have a device. We have few tags in this device. We have a tag group included in the device. We can also have tag group in a group. To do that, I can just create this group create button and I can name that group as I can highlight this group and create few tags here. So you will see we can have device, then a tag group in a device, and again a tag group in a tag group. This kind of data structure probably will be useful in actual day-to-day usage when you have a equipment and then certain pump in that equipment and certain properties of that particular pump, and then you have another pump for the same equipment or a third pump for the same equipment. So in those kind of cases you can create tag groups for a pump. You can have another tag group for another pump and so on. Now let's create one more device. And now just to show CSV import and export of tags, I am going to do following. I'm going to select this tag group. I want all these tags to be present for this device with little modifications. So what I'm going to do is select this tag group, go to tags, export tag group, export these group tags to ANSI CSV file. And you will see the file extension is CSV. The default name generated is group in group. And in this folder, this particular CSV file is going to be generated. So I click save and the CSV file is generated. Let me open up the Explorer and find where that file is generated. So I know in this drive, Modbus driver demo, this group in group.csv file is just generated. So I can open this file using Excel like program. So I'm just double clicking on this group and group. And I see this file, CSV file is here. Now I want the tags with just little modification. So let's say I want to have different addresses and different tag names for this. So I can say and so on. I'm not interested in these three tags, so I'm going to just delete them and change the addresses of these tags. I might also add description for this tag. And apply the same description with little changes. So I have modified the CSV file which was generated by exporting a tag group tags as a CSV file. I am now going to save that file, save, and it's giving me a warning that whether you want to keep the same file format, and I'm going to say yes. So this file is saved. I close this program, go to the driver, and I want those tags which we just modified to be included in this device. So I highlight this device, go to device and import tags from ANSI CSV file. So this is the file we created. So I'm going to just double click. So I see the two tags are successfully imported and it has given me an error that there was certain error while importing the tags. Let's go to that folder and find out what error was there. So it has created a error file groupingroup.txt. Let me open that file and see what error. So in line 4 there was an error in holding register address. Let me open that file and in line 4 I see the address I typed was a address which is not acceptable to the driver. As this is the example only, I am just going to forget about this error because this was just a demonstration. So we thus see that we can use this CSV file import export feature to quickly get the tags from this group to that group. You will see that there are two different CSV files which you can use. One is ANSI CSV files and Unicode CSV files. We find that the ANSI CSV files can be opened with a program like Excel. If you include some characters which are not ANSI characters in the tag names, then you should use Unicode CSV files. You can open Unicode and ANSI CSV files using Notepad-like program. I want to show you one more feature, one more way of exporting tags as a CSV file and then importing them directly in Infilink. Now I am selecting this channel and saying File and Export All Tags to ANSI CSV file. I am using the menu from File item, File, Export All Tags to ANSI CSV file, and in the status bar it is telling me that this export is for importing the tags into master application, which is Infilink. So I export all tags and give the name mod tags for Infilink. So I just remember where I have created this CSV file in the folder. I hit save. So now If I go open up Infilink, create a new project, and I want all these tags to be available in Infilink, I can do that with the file we just created. So I open up Infilink, design mode, create a new project. So I give a name, create. So to define Modbus tags, I go to tag groups. This is a icon or button for creating Modbus group tags. So I click this button. I give a name to the group. And instead of creating the tags one by one, I just right click this group item and import tags from ANSI CSV file. I use this menu item and I choose the file which we created last. So mod tags for infilink.csv was the file which we created. So I double click that file and we see that all the tags which we just created in the Modbus driver are now available in Infilink for use. Let us now look at some advanced settings for channels. When driver fails to connect to the channel IP address and port, it will attempt to reconnect after certain time duration. Driver will post messages of these connect successes or failures events into event logger pane. That time duration can be specified in the field attempt reconnect after so many seconds. You can also specify how many times driver should attempt to reconnect. If you enter 0 for this field, driver will keep attempting reconnect forever. Let us now understand about data write optimizations. Infilink can request tag data writes to the Modbus driver, which in turn sends those requests to Modbus device. Infilink, through its scripts or animations, can generate a lot of data write requests in very short period of time. Data writes in the device may not happen at that speed because of reasons like network speed, limited capability of the device to accept write requests at that speed, and so on. Modbus driver builds up internal queue for each tag for incoming data write requests and attempts to send all the data write requests to the device on first in first out basis. We need to optimize this operation in case the queues get long. Let us understand this problem with an example. Let us assume that the user is trying to change certain set point for temperature. Assume that the current value of set point is 50 and using a slider on HMI window, user is changing that set point to 70. As the user slides the slider, Infilink will send all in between tag values as data write requests to the driver. But it will be okay even if only the last value is sent to the driver and device, as that is the new set point. Such situation can have different effect in case of Boolean tag and non-Boolean tag. The driver allows you to have 3 different ways of optimization. You should use the setting which best suits your situation. You can use the lowest setting and tell the driver to write only last value for all tags, Boolean or non-Boolean. With the middle setting, you can tell the driver to write only latest values for non-Boolean tags, but write all in between values for Boolean tags. With the topmost setting, you can tell the driver to write all values for all the tags. Typically, driver will be always doing data read operation all the time. Data write requests will come occasionally. With this duty cycle setting, you can tell the driver to do certain number of write operations for one read cycle. Let us now look at some advanced settings for devices. While creating a device for a channel, you will see this setting. Generally, Modbus address space for coils is from 1 to 65,536. But there are devices out there which start their coil addresses from 0 instead of 1. To accommodate these kind of devices, this setting is provided. When this setting is false, coil address 1 will be treated as 1. When this setting is true, coil address 1 will be treated as 0. That is, driver will subtract 1 from the address and then request data for that address. Effect of this setting is for all address types, that is coils, inputs, holding registers and internal registers. Default value of this setting is true, but in most cases you will have to uncheck this setting and make it false. This setting is similar to earlier setting but applies for bit addressing of registers. When you are accessing bit status of a register, bit addresses will run from 0 to 15, 0 being least significant bit and 15 being most significant bit. This is how most programmers will like to see addresses, that is lowest address is of 0. But you can uncheck this setting and ask the driver to use bit addresses from 1 to 16. Bit 1 will be least significant bit in this case. This setting comes into effect only when individual bits of the register are being accessed. Let us now look at device demotion settings. You can have multiple devices connected to a channel. Driver will keep on polling all the devices one by one and keep getting data from them. It can happen that some device can get busy in its own processing of logic and may not be able to respond to data read requests. Device will typically send back device busy error code to the driver during this time period. Device may get to its normal processing after brief busy period. These settings allow you to handle this situation. You can tell the driver to treat a device as non-responsive for certain period of time after getting certain number of device busy error codes for successive data read requests. The device will be demoted for specified amount of time and no data read requests will be sent to that device during that demotion period. Driver will resume normal data read operations after specified demotion time period is over. You can also tell the driver to discard data write requests coming from Infilink during that demotion period. This setting causes the driver to swap the bytes of a read register value. For most of the devices, the default setting of true will be okay. But some devices assume different byte order within a register. In that case, you can uncheck this setting to accommodate those devices. This setting comes into effect when you use 32-bit data types for a tag. 32-bit or 4-byte data types are dword, long, and float. For these data types, driver reads two consecutive registers and combines the data together to get 32-bit data. By default, register with lower address is assumed to be low data word. If you uncheck this setting, then register with lower address will be used as high data word while combining the values together. This setting only comes into effect when you are accessing individual bits of a register. Normally, rightmost bit is the least significant bit, and that is assumed by default setting of false. But you can ask the driver to treat leftmost bit as least significant bit by setting the value of this setting to true. That's it, folks. With this information, I think you will have no difficulty in using this Infilink Modbus driver. Thanks for watching this video, and bye.